um, for the stock market and stuff, like for
Yeah.
finance.
Yeah.
Yeah.
Yeah. That's good stuff. I mean, hopefully some of the Excel stuff you learn in this class will be a step in the right direction there.
Yeah.
Yeah.
Actually, I enjoyed the exercises because it showed how to use different.
I'm glad.
Yeah.
I'm glad to hear that. And if any of those Excel exercises are too cumbersome, please let me know, because that's been a long process. Like first, getting that, the worksheet. Like the first time I taught this, I didn't even have that. And I got complaints that, you know, they were just wasting time putting in data, so I got that. And then I tried to cut out ones that are confusing. And I don't want you spending, 3 hours on your Excel worksheets. I want you spending like an hour, maybe 2. All right, so let's go ahead and pick this up. I think we're already to this point estimation concept. This point estimation is our sample mean. All right, so we're trying to estimate the whole population mean. We take a sample mean, and that's going to be what we'll call our point estimate. So that is our best guess. But we don't want just our best guess. We want an interval, because our best guess is probably going to be wrong. We want an interval, and we want to be able to say that we are a certain level of confident that within that interval is the true population mean. So our interval is going to be our sample mean plus or minus some amount. And in the quick example we did, it was 2 standard deviations. So all we need to know is what's the size of the standard deviation. Call this our confidence interval, our probability that the interval will in fact contain mu, which is the true population mean. Now, in our example, which we did a moment ago, we did 95.5% confident. But it could be any number. We could say we want to be 80% confident. We could say we want to be 90% confident. We could say we want to be 95. We could say we're going to be 99.7. We could say whatever we want. So let's just say, for example, we want to be 95% confident. I want to know how many standard deviations plus or minus I'm going to go from my point estimate, my sample mean. Now recall, when we wanted to be 95.5, we went 2 standard deviations. Now we only want to be 95% confident. How far are we going to go? Are we going to go less than 2 or more than 2?
Maybe a little less.
A little bit less than 2, exactly. So we're not going to go as far because we're going to be a half percentage less confident. So it's going to be like 1.98, 1.97, somewhere in there, right? All right, so if I want a 90% confidence interval, I'm going to take the sample mean, my point estimate, and I'm going to go plus a little bit less than 2 standard deviations, minus a little bit less than 2 standard deviations. Question to you is exactly how much? Plus or minus how much? Well, let's think about it. So this is my sampling distribution of the sample mean. Okay. If I'm 95% confident that that interval is going to contain the true mean, what's the chance of me making a mistake, of it not containing the true mean?
If you're at 90, what was it?
I'm 95% confident that it does contain the true population mean. It's confidence interval.
It'll be 5% off.
Exactly. So the 5% chance of me making a mistake. How does that 5% break down? Well, there's a 2.5% chance it could be too high, 2.5% chance it could be too low. All right, so this could be an error here. This could be an error here. 2.5% of the data in the sampling distribution of the sample mean is up here. 2.5% of the data in the sampling distribution of the sample mean is down here. So what I want from you all is the z-value that separates z. That separates the bottom 97.5% from the top 2.5%. Alright, 2.5% of the data is up here. You tell me the z-value that separates the upper 2.5% from the bottom 97.5%. You with me there? You like how you know how I got 97.5? Alright? So, how are you going to find it?
You look it up.
Do it. Go for it. You like your stack? You look in the back of the book. Exactly.
The back of it.
Oh, you don't have one. Calvin, you want to look on it? Maybe you could look on it if you don't have one. Or you've got it somewhere in there.
Is it on the last slides?
Appendix A. Oh yeah, it is. Yeah. Actually, it is. You can do that.
Yeah.
You can do it?
I have it here.
Yeah, do it.
Yeah.
You said it's in Appendix A?
Yeah, I think that's right.
$2.5. 0.9938.
0.99. All right. Do you have a guess yet?
Mm-hmm.
All right. So you're going to be looking here for 0.975.
Okay.
Yeah.
Oh, got it.
We're looking.
Let me see.
What are we looking for?
Let me
Oh,
see.
nine.
Yeah.
Oh,
Let me see your thing.
All
All right. So you're going to be looking here for 0.975.
Oh, okay.
And then you're going to tell me the z-score that corresponds with.
975. That's
Is it 1.9?
1.
Close.
1.96.
1.96.
Yes, you both got it at the same time. You're like twins. 1.96. All right, check it out, Michael. See if you can see that. Look in the center.
I can get it. I'm just trying to
Oh,
figure out
you're-
where all this table is. That's all I have is all this.
Yeah, so it's there. So go boom. You need to get a good grip here. There you go. Keep going. Keep going. No, no other way. Yep. Good. Yes. All right. So that's the negative side. Now go to the positive side. One more.
Oh, I was
Yeah,
looking.
keep going. All right. So now you're looking in the center of the graph for 0.975.
I'm looking for 0.975.
Yeah, in the center of the graph. You see it?
Yep.
All right. Once you see it, what's the z value on the outside of that?
1.9.
1.9, and you need to go over how many columns?
6.
Yes. Yeah, so the answer is 1.96.
Yeah, I couldn't find a table because I was looking for something that said z-score, and
Oh,
it's
sorry.
labeled cumulative normal probabilities, and I was like,
Alright, so you'll have it. Alright, you want a z-score of 1.96, and then you're going to be able to say I'm 95% confident. So you're going to go plus, you're going to take that point estimate, you're going to go plus 1.96 standard deviations, and you're going to go minus 1.96 standard deviations. Can you do another one?
Yeah, let's do one more.
Alright, how about I want to be 90% confident? Alright, if I'm 90% confident, right, and I'm 90% confident that my sample mean is going to fall within this range,
So it'll be 5 and 5.
yeah, be 5 and 5. 5% here, 5% here. So now, I want the z-value that separates the upper 95%, correction, the upper 5% and the bottom 95% of the data. So you're looking in the center of the table for 0.95.
Say that again.
You're looking in the center of the table, 0.95.
0.95.
Yes.
82.828.
0.828, where are you getting that? You're on alright, so find 0.95, and then you go,
0.9.
oh, right, no, where's 0.95? 0.95. No, that's 0.8 something. No, you wanna find 0.95 in the middle here.
Oh.
So
I
like
got
this is, see, this is 0.952, so that's too much. Yeah, so you wanna go right there.
Oh, okay.
Yeah, yeah, yeah.
1.64.
1.64.
I got you. I don't know.
1.64, got it, Catherine?
Yeah.
Got it, did you see that?
I don't have it here. I was trying to Google it.
No, you got it.
0.95?
Yeah, 0.95 in the middle.
Oh, okay.
Yeah.
Oh, yeah, yeah.
Can you see the z-score?
So even if it's 9495?
What's that?
Cause I
It's
don't,
between two, is that what you're getting at? You could choose
Yeah.
either one. You can choose either one. Or I think sometimes folks will go 0.645 because it's between 0.64 and 0.65.
yeah.
So,
You can go
0.645.
okay.
Either one is fine. Alright, so we need to go plus this, we need to go minus this. What I want you to do is look on the negative side. Look for 5%. Michael, look on the negative page for 5% and tell me the z-score associated with that. And you can't do this one, Calvin. You just have to listen.
What was the?
5%. So 0.05 in the center.
Roughly minus 1.6.
Minus
1.6.
1.6 what?
Between, if you rounded,
Yeah,
was
minus
0.4,
1.6465.
1.64. Minus
1.64, yeah. Minus 1.64.
Or 1.65.
Or 1.65. Okay, so you could do it either way. You could look on the negative side and get the negative 1.645, or you could look at the positive side and get the positive 1.645. The normal distribution is symmetrical like that. Look on the negative side, positive side, it doesn't matter which one. Either way. Alright, there's a process here you could go through. I think the best way is to do it exactly like we just did it. Say, alright, I want 90% confident, that means 5% chance of error on either side. So I want the z-value that separates the upper 5%, the bottom 95%. So that means I look in the center of the z-table for 0.95. And it's a little confusing because you're like, wait a minute, I thought it was 0.9. But no, you need to think this through. It's two tails. The chances of an error split either side.
Because there's two answers, right? Plus and minus.
Well, yes, yeah, plus or minus. And I think that's the best way to do it. You could also do this, like 1 minus the let's do 95%. So, if we're 95% confident, you do 1 minus the confidence level is 5%. Right? Divide 5% by 2, we get 2.5%. Subtract the resulting value from 1. 1 minus 2.5% is 0.975. Look on this value on the table. And when we looked at 0.975, we found 1.96.
Can I ask a quick question?
And yeah, go ahead.
When you're done.
No, go ahead, please, I'm done.
Let's say you were looking for a confidence level of 80%.
Yeah,
Then you would put 10 on each side and look for 90 on here, correct?
yes.
Yes.
And that's how you would get that.
Yeah, yeah.
Okay.
What do you get?
1.3 or
Yeah.
1.3
1.3?
and 1.31, or depending on how you round it, could be doing
Alright, so 1.3. So see, when you have a lower level of confidence, we started at 95, then we went to 90, now you're going to 80, you don't have to go as far with the standard deviations plus or minus.
Yeah.
Alright, so let's do some exercises. Let's turn to page 248 and look at exercise 7.4. I got you here, Calvin.
Yeah, I have it in my laptop, but I need somewhere to plug it in because my battery's.
Oh, can you plug it in like right there?
I don't on socket over
Alright, whatever.
Oh,
It's up to you. Don't worry about it, don't worry about it. And we're gonna get together and we'll work off of Catherine's. Alright,
Where's the page? I'm sorry.
it's on the slide, it's 248, I think. Alright, so let's see. This is an exercise that you have in your book, you can reflect back on later if anything confuses you, but let's do it together right now. For a random sample of 60 new BMW 528i's sold last year, the average time cars stayed on the lot before they sold were 97 days. Okay, so we're trying to figure out how much time these cars spend on the lot before they're sold. We don't want to call and ask the dealers, and we can't get all the information because the dealers just lie to you anyway, and it's just easier if we take a random sample. So, we want to build a 95% confidence interval estimate for the average time spent on the lot for all BMW 528i sold last year. Assume the standard deviation of the population is known to be 22 days. Okay? So we have a couple things here that are important to us. We have, out of our sample of 60, we found an average time on lot of 97 days. Alright, so we've got our N. Sample size is 60. Okay, what was our sample mean?
97.
97, excellent. Alright. And, oh, sure. And then we know our population standard deviation of 22 days. So this is the population standard deviation 22 days. Alright. We want a 95% confidence interval. Alright, now this is the first one we've done, so I'll remind you that the first thing we're going to need is we're going to need the standard deviation of the sampling distribution of the sample mean. Now the population standard deviation is 22. We need the standard deviation of the sampling distribution of the sample mean. Remember we said standard deviation of the sampling distribution of the sample mean, it's taller and skinnier, it's smaller. Okay? Do you remember how that's calculated?
The standard deviation divided by the square root of the sample.
Standard deviation divided by the square root of the sample size. So this is 22 divided by the square root of 60. Equals, what did we get? Just want to do that on the calculator right quick? Just tell me what it is.
It's 11. It came out weird. I don't even know if
I can't, just tell me what it is.
it's 11.
Times e to the 10,000? That's wrong.
No.
It's some number smaller than 22, right? It's like 11 could be a reasonable answer, I would believe you.
I'm gonna do the
If you get like 4,
Yeah.
22 divided by the square root of 60.
square root of 60, yeah.
It's telling me it's 2.84.
Alright, I like it, yeah, 2.84. Alright, that's better than 11 times e to the, times 10 to the 6 million. Alright, so the standard deviation of the sampling distribution of the sample mean is 2.84. Alright, so our point estimate is 97 days. So we want to go plus or minus 2.84 would give us a 68.3% confidence level, right? So we don't want 68.3, we want 95. So let's go plus or minus a certain number of these. So we just need to know how many z standard deviations plus or minus we need to go.
so that we could become 95% confident.
Yes. Alright, so if we're 95% confident, what are the chances of us making a mistake?
2.5 on either side.
Exactly, 5% total, 2.5 on either side. So we need the z value that separates the upper 2.5% from the bottom 97.5. And what do we know that z value to be? 1.96. So, our confidence interval then is going to be 97 plus or minus 1.96 times 2.84. That's it. So let's do the minus side first. Let's do 1.96 times 2.84, maybe put a minus sign on that, and add it to 97, or however it's more comfortable for you to do in your calculator. 97 minus 1.96 times 2.84, if you use parentheses. Whatever you need to do to get the minus side of that.
Minus 97, so would it be negative 91.43? No? Did I do it wrong?
Alright, so this is almost 2, this is almost 3, so it's going to be about 97 minus about 6. Yeah, so it's going to be about 91 point something. What'd you get, Calvin?
Wait, I'm sorry, 1.96, so it's 1.96 times 2.84, minus 97, now.
97 minus, so you don't want to...
Oh,
91.44.
I like that. 91.44. Alright, that's the lower bound of our confidence interval. Yes, question?
I'm sorry.
Just watch.
I know,
Here, let me get you.
let's see a towel or something.
Look at the,
And then maybe I can try to work a little bit with this.
yeah. Here, why don't you have a drink? Just a little water?
Yeah.
Pictures, yeah.
Thank goodness. That's what I needed.
Alright, so the lower bound of our confidence interval is 91.44. What's the upper bound?
102.55?
How much?
102.55?
102.55. Alright,
57, sorry.
alright, and this is how the interpretation goes. We go back to our manager, go back to the investors, and we say, I am 95% confident that the true population mean, or the true average waiting time for the whole population, is between 91.44 and 102.57. Does that make sense?
Yeah, but can I have a question?
Yes, of course.
Yeah, I'm thinking that, no, I'm okay, can I go outside for a minute?
Okay.
Just for a minute.
Okay. Alright, do you guys mind if I take